So I'd like to introduce now our last speaker here for the morning, Mariah Rufer. And the topic is how our Itasca County lakes are doing. Mariah earned her bachelor's degree in biology from the College of St. Benedict, St. John's University in Collegeville, Minnesota, and a master's degree in aquatic ecology with a focus on lakes from the University of Minnesota Twin Cities. She has 10 years experience working with lake associations and conducting lake monitoring programs and studies. Mariah has completed 232 lake reports in 15 different counties. She enjoys working directly with lake residents and teaching them about lakes and how to protect them. So please welcome Mariah.
Thank you. I'm going to, does this work? Oh yeah. I'm going to try and use this because I have kind of a cold right now, so I don't want to, if I strain my voice too much, I'll start coughing, so I don't want to do that.
A question before you start, Mariah. Is this watershed specific? In other words,
This is lake specific.
the whole county?
Yep.
Okay, all three watersheds.
Mm-hmm. Yep. So what I'm going to start with is what data you actually need to be able to do this trend analysis, and then I'm going to go into Itasca County specifically and talk about the lakes that we've already completed as part of a study that's going on right now, and the lakes that have enough data to do this analysis in the future. So we're going to get very specific. We're going to start broad and we're going to end very specific. So hopefully I'll address questions as we go here. So first of all, I like to focus on what data is needed for this type of analysis. It's very important to have quality data for this. And the data that's been provided for these analyses usually is coming from volunteer monitors on the lakes. And those lake volunteers that are out there taking secchi disc readings every week, every couple of weeks, that is such valuable information. And if we can get that information year after year, which is what I'm going to talk about here, it just makes the most valuable data set, and it's something that's contributed from the lake residents and the lake associations and can be used by the state, the counties, and everything in between. So working at a lab, we get a lot of questions about how to set up your monitoring program. A lot of people want to just take a quick sample from that spot over there and a little grab sample from that spot over there, and maybe this time I'll get that stream over there, and then this other time I'll get that culvert over there. Without having an actual purpose and planning to your monitoring, it's not a really good use of funds. So we like to work with people first and make sure, okay, what are your goals for monitoring? What questions are you trying to answer? And let's set this up so that you can actually answer those questions in a good way and minimize the amount of money you're spending. Because if you're just doing all these little sites and changing it every time, it's not that valuable of data, because one data point can't really tell you very much, except for what was happening that one time, that one day. So before you even start spending any money on monitoring, we've got to set up the monitoring program. So monitoring purpose. For lakes, there's three main purposes. The first one, well, I'm going to go backwards. The one-time check, that's what that's that grab sample. Oh, I think there was some septic system might be failing over here. Let's do a quick grab from that. That type of monitoring is actually really, really hard to even detect the problem, because as you know, lakes have a lot of water, and a lot of water is very good at diluting anything that goes into it. So unless you get a sample from the perfect spot at the perfect time, you can't even catch a failing septic system or some other problem. Maybe if you're going out there during a really heavy downpour, you could catch some runoff. But into a lake, it is diluting right when it gets into it. So it's really hard to catch those spots. Sometimes it is useful though, like with that runoff. Then the other way to do monitoring is your statewide assessment. So the Minnesota Pollution Control Agency does the assessment of the water quality. They put out the impaired waters list every 2 years. And to have your lake analyzed for this assessment, you need to monitor for 2 years. And Itasca County has done this on, I have the number, but it's a lot of lakes. 226 lakes I found in the statewide database that have this 2-year data on it from just Itasca County. And that's from that effort that was started in 2008, I think, through the community college lab here. And I think IWELP was involved, where you did all that monitoring on all those lakes. So that was excellent in getting that 2-year data set on all the lakes. And that enabled them to get assessed through the statewide assessments. Then the next step up the chain is the long-term condition and trend monitoring. So once you have a couple years, if you stop, then your data set breaks and you're done on the data looking into the future. But if you're doing the long-term condition and trend monitoring, so this is what people a lot of time want to know. How are our lakes doing? When I tell people what I do for a living, I usually just say I'm a lake biologist. And the first question is, oh, how are the lakes doing? It's like, well, it really depends on which lake, because every lake's different. And you'll see it's not a uniform thing. They're not all declining. They're not all stable. Each lake is very individual in what's happening on it. So it depends on the lake, but it also depends on, do we have enough data to even answer that question on this lake? So in order to do the long-term condition and trends, you need enough data, and so you need to keep monitoring. And maybe that just means doing the Secchi disc monitoring, which doesn't cost any money, but it takes volunteer time. So now I'm going to focus on that long-term trend and condition monitoring and go a little bit deeper into how we do that, and then how we answer questions using that data. So to set up your long-term trend data set, so that's our purpose. Next, we need to choose our monitoring sites. This is very important, where you take the sample in the lake. You want to do one primary site for the lake if it's a generally round, not overly large lake. If it's a large lake with a lot of basins like Deer, it's a little harder to pick a primary site on a lake like that. But it's still possible to do that. But usually, it's in the deepest spot of the lake towards the middle of the lake. Always have your know what your primary site is. And the lakes I'm going to talk about today, I've determined what their primary site is or should be. Always monitor that same primary site every year. You can do additional sites on top of that if you want to, but never stop that primary site. Otherwise, you break that continuity in your data set. If you say you did this bay for 3 years, and then you switched and did this bay for 3 years, and then you switched and did that bay for 3 years, you can't do a trend analysis on any of them. But if you have your primary site, which you do for 20 years in a row, and then you did this one for 5 years and saw that, oh, it's not really that much different from this site, I don't think we need to keep doing this one. Or maybe you started doing this site for a few years and noticed, oh, that clarity is a lot different than this one. We should keep monitoring both of them because that bay is a lot different. So there's kind of things you can go work through to see if it's even necessary to do an additional site or not. But always do that same primary site. It's very important to get enough data every year to get a good seasonal average. So we recommend at least 4 to 5 times per summer, evenly spaced May through September. If you collect less than 4 samples, you can't calculate a good average. So if you're only taking 2 samples in the summer, you can't really get a good average because say you just took 2 samples in July. Well, that's only really telling you what's going on in July. So we want an average of the whole summer. And then I'm going to talk about this more, but the reason we do it over so many years is because each year has variation year to year. So that's why you need to look at a lot of years in a row to do the trend analysis. So getting enough data every year and evenly spacing it once a month is also very important. For the parameters, this seems super boring to just do the same thing every year. Phosphorus, which is your TP is total phosphorus. That's your main nutrient that's feeding the plants and algae in the lake. So the more phosphorus that's in the lake, usually the greener it is, the more algae there is. Chlorophyll A is the pigment in the algae that makes them green. So it's basically testing the algae concentration in the lake or how green the water is. And then transparency is the Secchi disk. And all three of these parameters are related. So we want to do all three of them on the same day together. The phosphorus is that main food for the lake. So if you have more phosphorus, you're going to have more algae. So usually as the phosphorus increases, the algae increases too. And then when you get greener water, the transparency will decrease. And usually we see those three things changing together. Now, the 4 to 5 data points a year is a good recommendation for the phosphorus and chlorophyll A monitoring. And it's a bare minimum for the Secchi disk monitoring. And as I'm talking here, I just want to tell you too, I do have all of these monitoring guidelines in a handout that's here and over there. So at the end, you can pick those up too if you want to do that. So for Secchi disk monitoring, 4 to 5 times a summer is the bare minimum. It's a lot better to do that every week if you can. Every other week is fine too. The bare minimum would be 4 to 5 times a year. So what we recommend to people is to do our program along with the MPCA's Citizen Lake Monitoring Program. On the days that you take your water sample, you also do a Secchi disk reading and put it on your data sheet with your water sample. Then on the off weeks where you're only doing Secchi disk, you put that on your PCA CLMP data sheet, and then that goes straight down to the state. So if you monitor your Secchi disk weekly, you're really going to catch those seasonal ups and downs in the lake and find out the pattern of the lake. So like I said, site selection is very important. We can help you with a map of where your sites are, what their codes are, and which ones you should be using. Most of your lakes already have these sites established by the PCA because there's data there. If there's past data and we don't know where it's from, we can't use it in a trend analysis because what if it's, when I pull up data for lakes, I often see sites that are, right along here, like someone was just doing a Secchi disk reading off their dock. Well, that might be fine for you if you're comparing that every year, but if you're going to do a whole nice lake report on the whole report or on the whole lake and its data, you don't want to use that spot as your main monitoring spot. It's not representative of the lake. So when we're looking at trends, what we're looking at is the water quality over time, and is the water quality improving, declining, or staying the same? And we're using a statistical calculation here. So what we're doing mathematically is seeing what's the probability that the data is showing some kind of trend happening, and what's the probability that it's just a random result of the data. This is an example of a lake that has a very stable, this is Toad Lake over by Detroit Lakes. The Secchi disk mean has been stable since 1991. And as you can also see, one other thing we really look at are this is the actual data points. It's not means, it's actual data points. We look at the maximums every year and the minimums every year too. So as you can see, they hit this, usually your maximum Secchi disk reading is going to come early June when the lake first starts stratifying. There's tons of Daphne out there eating the algae. You get this really, really clear water late May, early June after the lake does that spring turnover. And so you'll see, this lake hits a 25-foot peak almost every year. And so that's another thing that's telling me this is really stable. Also, the lowest Secchi that you usually see is going to be August when you're seeing algae blooms. And those low ones look about the same too. So to do a trend analysis, we need 8 to 10 years of data from every year. When I'm doing these analyses, I will look over maybe a 1-year gap, maybe a 2-year gap, but if I see a change from the before the gap and the after the gap, then I don't feel comfortable assuming what happened those couple years that we didn't have data. A good example of this is there's a lake in Ottertail County right now, West Olaf Lake, that monitored up until about 5 years ago. And all of a sudden this year, well, a couple years ago, a wetland next to it was overflowing, and so they pumped into this lake. And now this lake's having huge blue-green algae blooms. But we don't have any data from the last 5 years, so we don't know when this change happened. We don't know what changed, like the phosphorus levels, how they changed, how the chlorophyll A levels changed. And now they're going to start monitoring again. But we missed that critical time of when this problem started happening. We could have caught it earlier. If you're monitoring every year and you see a change like that, you can catch it right away before it gets so far past the point. And like I said, the reason we have to do this after 8 to 10 years and not just 3 or 2 is because there's different wet years, there are different dry years. Different things will affect the clarity year to year. You know, when the ice went off, when the turnover happened, when the lake stratified, all sorts of different things. So we want to kind of generalize that over a longer time period. So this is just kind of a recap, because this is so important, a recap of what I've been saying. So to do the trends, you need to stick with the one primary site. You need at least those 4 data points a year. We want consistent data points each year in a row. So if you do monitoring for 2 years, take 3 years off, then you do 2 years, 3 years off, 2 years. You can't do a trend analysis on that data set. So what that's doing is just telling you every few years how your lake's doing. You're kind of checking in. And we want a consistent seasonal spread each year too. That means don't take all 4 samples in July. You want to spread it out between May and September. Just the statistic that we use is called a Mann-Kendall statistic. And like I said, we're looking at the probability. So we want a probability of over 90%. We want it to be over 90% to even say that there's a trend. So this is saying that there's a 90% chance that the data is showing a true trend and a 10% chance that it's just a random result of the data. And our program that we use for this will tell us, you know, if it's 90%, 95%, and then we even have some trends that tell us it's 99.9% true that there's a trend. Now those ones you can be very, very sure of. So when I'm doing a trend analysis, I look at each lake individually, and you can run data through a trend analysis program, but because these results can have implications for the area on which lakes have an improving or declining trend, I like to be very, very conservative when I'm looking at this data and make sure that I am comfortable with what I'm reporting. So first of all, like I said, I look at the data each year, make sure I see how many data points they have for each year. I see which site it's coming from. I look at the annual means, I look at the annual minimums and the annual maximums. Here's an example of a lake in Ottertail County where all 3 for chlorophyll A, so this is the algae concentration, the mean, the minimum, and the maximum are increasing. So a lot of times you'll see the same pattern in all 3 of those measurements, and that's when you can be pretty confident that what you're seeing as the results here is happening in the lake. So another thing just to note is that a trend can be a result of human causes, or sometimes it's natural causes. Sometimes it's a landlocked lake and it's just groundwater fed and there's natural water level fluctuations, and that can affect the clarity over time too. Usually if it's a declining trend, it seems to be a human cause. If it's an improving trend, sometimes it's hard to know. Maybe there is a lake, I've done so many now, I don't remember which one, but it's one in Todd County that has an improving trend, and they have done major work with farmers around the area with grants through the SWCD, and I think that those projects are really showing a change for the better in that lake, and it's great when we can point that out and say, hey, these projects are working, and these grant dollars were being spent really well. So just as I like to just touch on what's happening in the lakes if it is changing. Eutrophication is a natural process that happens in the lakes. So our lakes here in Minnesota are relatively young. The glaciers left about 10,000 years ago and carved out our lakes. And as a very slow process, they're filling in with nutrients and sediments. But this is naturally a very, very slow process that happens over thousands of years. So the problem is that humans speed up that process because we change the landscape and make that runoff of nutrients and sediment happen faster than it would be naturally. So that's human or cultural eutrophication. And just to show you in numbers, these first 4 land uses. So this is the phosphorus runoff from prairies, forest, wetlands, and then these are human land uses and the phosphorus export. So pasture land is not too bad because a lot of times it's similar to prairie, but agriculture and urban, so this would be impervious surface, are putting a lot more concentrated phosphorus into the lakes than it would be. So just think about our lakes. If humans weren't here, these would be the only phosphorus sources. So they're very, very slow moving over time, whereas we're speeding that up. The culture and agriculture and urban is very similar in the runoff. It's where the change in the agriculture then is if you get to the feedlots where the nutrients are very, very concentrated. So on to the specifics now for Itasca County. I kind of set the stage for what we're going to see here. So if you raise your hand if you were at Dan Stewart's Minor Watersheds talk. Okay, just a few of you. He talked about this process, and they're doing this in Crow Wing County. Last year, Itasca County joined with Crow Wing on a grant application. This was Noel Greasy, who used to be at the SWCD, worked with Mitch Brinks at Crow Wing County to get this grant to start doing these reports and assessments on Itasca County lakes, and then these can be used for the water plan because the Itasca's water plan is coming up in the next year or 2, I think. They're kind of starting the process right now. So this grant application was for producing an assessment report. It's a 20-page report that we've developed with Crow Wing, Cass, and Aiken counties and the Board of Soil and Water Resources. It gives a evaluation of all the lake data, the trends, looks at the lake shed, and tries to narrow down what impacts could be happening on each of these lakes. And so this grant includes this analysis for 37 lakes in Itasca County. So right now I'm working on those, and we hope to have them done by the end of this year. So they're getting close to being finished, and I've completed the trend analysis portion on all these lakes, so that's what I'm going to talk about next. I've looked at all the data for Itasca County. Well, I should talk about that in more detail after this, but there are 35 more lakes in the county that have enough data to do Secchi trends. So I'm going to report today on the 37 lakes that we're currently looking at, and there's 35 additional lakes that could be included in this same assessment, and I'm actually going to tell you which lakes those are too. Now, as a little caveat to this, the data set I'm talking about is what I took out of the Minnesota Pollution Control Agency's statewide EQUIS database. So they have a database down there that is kind of the holding center for all the data collected in the state. The problem is they only have the data if we send it to them. So some programs send their data down there and some don't. If you've been doing the Secchi disk monitoring through the CLMP program, your data is down there, and that's what I gathered for this analysis. So I'm pretty confident that I have most of the Secchi disk data from the Itasca County lakes, because there was a lot of good, like you can see here, there's, do some quick math, 72 lakes in the county with enough data for Secchi trends. So I'm pretty sure I have all that data. What I don't have is the phosphorus and chlorophyll A data that's been collected on some lakes in the county in past years. There's various different programs that have been monitoring in the past, and so I talked to the Itasca Cola about this. I was going to give them a spreadsheet of what data exists at the state for which lakes, and then you can look at your lake and say, oh, I think they're missing some years. And then you can talk to your lake association and say, okay, who did the analysis during these years? And then we need to call them up and get that data, and then get it down to the state, and then I can get it for these reports. So I've talked to some lakes already. I've talked to Dave about Wabana. So we're starting that process, but it was my understanding that the data has been collected from a few different places. I think we're still working through it. I think most of the stuff that was collected through the ICC lab, I think, is in the state. But older data that was maybe through other labs in the area might not be down there. So you could talk to me. I actually have a sheet here that has it. So if you afterwards, if you want to know, you can talk to me. And I'm going to give this to the COLA to put on their website so that you can look at it there and figure it out. So we got to track all this data down, and then we can get some really good reports out of it.
Right, those 37 lakes that you have,
Yeah.
is there a list? Where's that listed?
I have it on a slide here, and I could also email that to you to post.
Okay.
So I'm going to go right into it here. Okay, so there were 37 lakes that I did the trend analysis for. These lakes are ones that are getting these reports done on them right now. And then these can be used for the water plan, so these can go into that water plan update. So these are the lakes that we analyzed that are stable. So that means no trend detected. There was enough data to do the analysis, and we didn't detect any trends. If there is more than one lake with that name, I put the lake ID behind it because there's 2 Deer lakes. So this is Deer, Balsam, Bellow, Burnt Shanty, Cutfoot Sioux, Dixon, Dora, Fifth Chain, Five Island, Grave, Horseshoe, Island, Jesse, Little Jesse, Loon, Pokegama, Rice, Sand, Shallow, and Trout. I should note too that the 37 lakes that were picked for this, they were picked because either they had enough data or they were some kind of priority to the county. And they were picked by the SWCD staff at the time.
Do you know trout, is that the trout in Coal Range or the trout by Wabana?
I have the lake ID.
Coal Range?
Our data would
It's trout. Yeah, this isn't going to tell you where it is, but it's the ID. It's 1,900 acres, so it's a really, really big one.
Yeah, that's Coal Range, thank you.
Okay. And it's, it's 31-216.
So the 37 that you're doing for the Bowser grant,
Mm-hmm.
is there a chance that we can still add to that and put some more work on your desk, Mariah, or?
Not right now. That grant, was done and the work's being done, but there's a new one open right now. That I think is due at the end of August, that you could add those, that you could apply for the other 35. That's open right now, actually. Okay, here are the improving trends, and this was actually a lot. What we've been finding is, most of the lakes in the counties we've been looking at are stable, and then there's usually 5 or 6 improving and 5 or 6 declining. It just seems to be the pattern. But this is pretty good, actually. There's 8. So bass, buck, north star, sand, the other deer, swan, turtle, and caribou. And do the people know which deer is which? I could tell you the size of it. I don't have the township that it's in.
North or south?
This one is 719. So this is the really, really big deer, the 4,000 acre deer. The other one was the other one's large too, but it's 1,800 acres.
Sand Lake
Sand lakes on 2 different lists. Yeah.
There might be 2 sands. There are. There's a 3,700 acre sand. Oh, I don't have which one is this one. I'll look it up though. I've got. Okay. Okay, I'll look it up at the end, but I have which one's which. So if you're on sand, you're either stable or improving. I'll find it for you at the end, though. I just want to dig while everyone's sitting here. Okay. And then declining, there were just 4. Battle, Beatrice, Gum, Gun, and Round, Clear. That's just how the name was in the database. So does that make sense on which ones those are?
That must be Gun Lake, not Gum. Gun Lake, north of Grand Rapids. Yeah, like north of Marcel.
It's only 32 acres. That Gun, it's very small. And Round is only 100 acres, so it's the small one. The small Round. Okay. So the additional lakes, I have 2 slides worth, but these are the lakes that have enough data to do the Secchi trend analysis, but we haven't done it. So these could be part of a future grant application that could be done.
Only Secchi though, right?
This is only Secchi. If I get, and none of these had there were only about 5 that had enough to do the trend analysis on the phosphorus with the data set that I have, but I'm thinking maybe if there's more data out there that I don't have, that maybe we could do them on phosphorus too. But these have enough Secchi DISC data in the state database that I actually have. I have this data right now. It's sitting there that I could do a trend analysis on. So these are Amen, Blue Water, Boy, Burroughs, Clearwater, Dunning, East Smith, Guile, Gun, 2 Hales, Hart, Jack the Horse, Little Bowstring, Little Dead Horse, Little Jesse, Little Long, Little Trout, Little Wabana, Maki, McGuire, Moose, Napoleon, Natures, Pickerel, Prairie, Scrapper, Sissibacquet, Snaptail, South Sugar, 3 Island, Trestle, Trout, Wabana, and White Swan. So 35 more lakes, that's a lot.
Jesse showed up on your first slide showing
Yeah,
the had a trend, and then now it showed up here.
I saw that. Let me see if it's a different Little Jesse. There can't be 2 Little Jessies, can there? Okay, so Little Jesse's being done right now. So I should take that off of this slide.
I think Sissibacquet, I'm pretty sure that they have enough data too, but it's probably not in the database.
The phosphorus? Yep.
And I think we're on the way to getting you a lot of it.
Great.
I don't know about the gaps. I mean,
Yep.
you started talking gaps, that may be a problem.
Okay. Yeah, get us the data and we'll look through it and tell you.
Gap, or what did you say?
Yeah, if you have, 5 years and then maybe a 3-year gap and another 5 years, I'll do a trend analysis across it. If it's stable across the whole thing, then it's probably safe to say it's stable the whole way because you're not going to see it go like this. So I'll still look at it. If you have 5 years and 3 or 4 years off, and then the next 5 years are higher, then we don't, and I'll just report, and I'll actually explain that in the report. We try and get as specific as we can. So I don't like to assume what happened those years that we don't have data for them. But if it's stable through that gap, then it's probably okay.
Viral statistics don't count.
Viral?
Word of mouth.
Oh, yeah. Yeah, it's helpful if someone says it used to be more, the lake used to be clearer than it is now. Sometimes the data will agree with that, and sometimes it won't. But it's nice if you have data. Your question?
Does your testing identify contributing factors like eDNA, et cetera?
eDNA of,
Like why the lake is getting clear? Is it sand is getting clear because of zebra mussels?
oh. We look at the lake shed around the lake. We look at what could be possible lake impacts. Are there inlets to the lake, or is it groundwater fed? How developed is the lake shore? How many tiers out is the development? So we try and, if I see a trend in the data, I try and figure out why. We also try and talk to the locals because they sometimes know, oh, there was some big change that happened, that, you know, that feedlot over there converted to a pasture, or the lake went on city sewer, or, you know, sometimes something like that happens and really changes the water quality, and a lot of times the locals know that, and I can't necessarily get that from our mapping tools and our data that we're looking at. So I do like to talk, before, we like to go through a draft phase of the reports where local people on the lakes can review them and then tell us if there's more information that would help, and then do a revision after that, because the locals a lot of times know. There's even things, you know, we use data from mapping tools, and sometimes people say, oh, that thing that you say is an inlet, that's actually an outlet, or, you know, something like that. So it's really helpful to get the local input first. We usually post them to a website and kind of have a review period and then incorporate the comments. As far as zebra mussels, they are changing lakes in interesting ways, and we're still figuring it out because it hasn't been very long in Minnesota yet. Mille Lacs is one of the longest inland lakes that's been infested, but over in Detroit Lakes area, Pelican Lake has been infested since 2009, so 6 years, and they probably had them a year ahead of that because the mussels we found were an inch big already. And we're starting to see in that lake, the clarity is ridiculous. I mean, it's 5 feet better clarity, but we're also seeing that because it's so clear, there's more aquatic plants, aquatic vegetation out deeper because the water's reaching the sunlight's reaching the bottom of the lake in deeper areas, and also the zebra mussels are producing waste down at the bottom of the lake that's feeding the plants, but also what we're seeing is the zebra mussels are filtering out all the nice little small-celled algae that the zooplankton like to eat, clearing out the water column, but that stringy green filamentous algae at the bottom, they don't eat that, and their waste is feeding that. So we're seeing really clear water, and then we're seeing rocks covered with zebra mussels and stringy green algae. So, you know, I don't know if that's necessarily better. You have clear water, your water's more clear, but the lake, we're just starting to see those changes, and I think they're seeing them in Alexandria too. So we're just kind of starting to get the first observations back on what could be happening from the long term of the zebra mussels in the lake. And it definitely is changing the fish behavior. Pelican used to be well, it's a good walleye lake, but it's turning into more of a night fishing lake because it's so clear that the walleyes can see you, and so you have to fish at night to catch them. So there's still, the DNR is doing fishery studies, and their catches are consistent, but people are saying they can't catch as many walleyes. But I think it's just they're changing their behavior because of the more clear water.
Okay, we can go all day without talking about walleyes on the last, please.
Yeah.
Mariah, do you guys have any kind of test sites set up for tracking chloride from salt into any water bodies?
There are a lot of metro area lakes that are doing that.
Okay. Are you guys
Yeah.
involved with that?
Yeah, we run the chloride analysis. We can do that. Yeah.
So that's a possibility to try to do up here too, considering
Yeah.
that you're expanding the spreading of salt on the roads.
Yeah, especially if you have a large road next to you. So like North Long Lake by Brainerd, 371 goes right by there, and they have a bay on that end, and that bay on that end has higher chloride than the rest of the lake. So it's probably coming off 371. So if you have a big highway like that, that could be definitely impacting. Although it's all relative on where you're at. So the chloride levels in the metro area, I mean, so high compared to what you'd see up here. I mean, up here, because everything dilutes first, so it depends on how big the lake is and how much they salt. But you might see a change from 1 milligram, or no, probably, I'm trying to think. Yeah, probably 1 milligram per liter to 2 milligrams per liter, where in the cities they're looking at like 100 to, I think it's.
Does that have on the lake?
It can affect the, I'm just looking at what, yeah, it's 2 milligrams per liter. So The range for this area would be 0.6 to 1.2 milligrams per liter of chloride, and you're probably not going to get much over that.
Those chemical parameters, when you're testing the water, are we doing salinity or no? Or chloride?
It's not a typical one. It's one you could test for maybe a year to see, but it's not going to change year to year like phosphorus does. And
It would be kind of nice to have some baselines and something.
yeah, and there actually is some. It's going to be in these reports if there is some. So if, a lot of times if the PCA comes in and does a 1 or 2 year study, they'll test that. So there is chloride data for some lakes, I'm sure, that we can look at and see what kind of levels. I'm guessing they're really low though. But the chloride can affect the plant growth and just the overall health of the lake. It can also stratify. Okay, so as a conclusion, for monitoring, think about the goals for your monitoring program before you start spending money on water testing. Make sure that you have your primary site for each lake, and I have determined that for these 37 lakes that are being analyzed right now. And if you want to email me about your specific lake, if you're one of the ones getting the reports right now, I do have my card over there and then at our booth here. Because I don't have all the data with me today. I have some things here, but not everything. Commit to SecuDisc monitoring because that's free. I always tell lakes there's no reason not to keep doing that. And like I said, once a month is a bare minimum. If you can do every other week, even better. If you can do weekly, even better. So that's very, very valuable information. And we've kind of addressed questions. I'm not sure where I'm at with time either, but any other questions in the back?
Yeah, is there any merit or efficacy in doing such a disc on rivers or streams?
That's a different program, actually. The Pollution Control Agency has a citizen stream monitoring program as well. And you use a different thing. It's called a transparency tube. So does the PCA have a booth here with that info? No?
No, we don't, but it's
Okay.
a Secchi tube.
Yep.
It's 100 centimeters, and there's a mini Secchi disc in there.
Yeah, so that's another thing that would be great to do that volunteers can do to monitor, and you also track rainfall and precipitation. So on the CLMP, or on the MPCA's website, you can look under volunteer monitoring, and there's the stream program, and you can sign up for that. And all that data goes right back to them, so it's accessible by anybody, which is nice.
Quick question. So your trend analysis is based off Secchi data, right?
Yes. So these were just clarity trends
Okay.
today.
Do you find similar comparisons with the MPCA's website? Because I know that we spend a lot of time and money building an algorithm that does long-term trend monitoring.
Mm-hmm.
And so there's a graph that kicks out. Are your results consistent with that?
Yeah, I do check with that and see what their results are. Usually it agrees, but I should talk to who's doing that to see if we're using the same methods. But usually it does agree, because I do double check that. It never disagrees so much where they would say it's improving and we would say it's declining. It usually agrees, and if it doesn't agree, it's a change between a stable or a improving, or a stable and a declining. Any other questions? Thank you.